Good morning. My name is Justin Biziano. I'm with Team 18, E-Vocality, and I'll start this presentation off. Our project is the model R310 Electrolarynx with Bluetooth capabilities and alert system. This is a sponsored project with Romet Inc. So here's the team. Again, I am Justin Biziano. I'm the project design lead. Michael Mesa is the documentation and hardware lead. Angus Fraser is going to be the software lead, and Hussein Alamar is the PCB design lead. So as I'm sure you're wondering, what is an electrolarynx? An electrolarynx is a device that is going to mimic the vibrations that are created by the vocal cords in the larynx to produce sound or speech. The users of this device will be able to place the top cap of the electrolarynx at the sweet spot of the neck and mouth the intended speech to have an audio output. Target consumers for this device are individuals who have suffered from cancer of the larynx that needed to have their larynx removed. And the target consumers tend to be in the age range of 50 to 80 years of age and have health concerns that may leave them bedridden.
I'm Michael Mesa, and I will be presenting our design. So the design is an alert system that allows laryngectomy patients to get the attention of caregivers from a much greater distance than an electrolarynx alone would be able to project. Caregivers could be in a different room and be able to respond to their patients quickly with a Bluetooth alert system. So the details of our design is that we have uploaded pre-recorded messages onto an in-house designed PCB, button activation that delivers messages to Bluetooth connected loudspeakers, and a compact design of microphone and PCB. And for our scheduling, we followed our Gantt chart that we produced on Monday.com to keep track of our tasks throughout the semester, making sure we notify each other when a task was completed so that we could follow up with the next progression of our development. So for our final design, it is different from our initial plans. So initially we wanted a electrolarynx with a Bluetooth connection to a loudspeaker, physical audio filtration, live audio streaming, and a built-in microphone. Throughout some changes in the semester, we ended up with a final design that still allowed Bluetooth connection to a loudspeaker, but instead it became an alert system for caregivers. We would upload pre-recorded messages to our ESP32 and have software filtered audio messages to be used with button activation.
Hello, I am Angus Fraser. I will be presenting about the challenges we encountered in our design. For software, we had Bluetooth connectivity establishment issues and limited resources for I2S audio data streaming, and finding workarounds for using macOS and setting up our IDEs and learning the Arduino syntax. Scheduling, we had hectic work and class overlap between group members. For hardware, we had audio filtration efforts discontinued late into our design process, as well as learning and building that audio filter circuit. And we had back order of our parts for our PCB and limited memory on our ESP32 boards in the PCB, and learning the Eagle PCB designer.
So we're going to
and here is a video demonstration of our prototype.
With our alert system for our ESP32 board.
Battery medium. Connected to ESP82 DPSRC.
So that's showing our Bluetooth connectivity to our board that we are programming. Once we press this button, it's going to demonstrate the alert system.
Help, I need assistance.
We will eventually add more buttons to have more pre-recorded audio that can be utilized for the user of an electrolarynx. Down here we have the flow of what our prototype is going to be. Unfortunately, we do not have it finished, but essentially this is going to be the top head of an electrolarynx. We are going to solder these wires to this battery terminal connector, which will also be connected to our buck converter, which is going to step down our voltage to the operating voltage of our PCB board that we have created.
Hello, I'm Hussein Alamar. Our team contribution are Justin Biziano. He is a project design lead. He review all final assignment design process and any change made to a design. Worked mainly on a software audio transmission. Michael Mees, he is a hardware documentation lead. He designed original audio filter circuit from scratch. and later work on a software for a Bluetooth connectivity with the Angus. Angus Phrase, he's a software design. He's setting up of a software design environment. Worked on a design for a Bluetooth connectivity using a source code with Michael. Hussein Al Omar, he is a BC board design lead. Research necessary component and a chip for a board. Made a sure BC board matched the dimension of R310 model. Some future plans for this device include reintroducing the built-in microphone from the initial design for users to create a customized recording, as well as the phone application for control of that process, and choose more robust hardware for memory.
So here is the poster that we created for the tech symposium. So in conclusion, the remodeled R310 Electrolarynx with a Bluetooth connectivity and pre-recorded audio alert system will overall improve quality of life and offer peace of mind for individuals who need an electrolarynx in order to communicate. The challenges that we faced as a team during the duration of this project made it difficult to finish the initial design we had intended for real-time audio transmission via Bluetooth. Although our final design strayed a bit from our initial design, we were able to create a custom-built PCB that had Bluetooth capabilities and offer pre-recorded audio recordings to play in case of an emergency. So the acknowledgments for this project go out to Dr. Patrick Benavides at the University of Texas at San Antonio, Nicholas Gallardo at G2 Consulting, and our sponsor and owner of Romet, Tom Dodson. And that will end our presentation. Thank you, and we'll take questions.